Newton's second law of motion, right? Basically, Newton's second law of motion is about total force equal to ma, yeah? Total F equal to ma, or resultant force equal to ma. We've got acceleration one, yeah? Got acceleration. Last time Newton first law is total F equal to 0, equilibrium, yeah? Total force equal to 0. Now this time, Newton's second law is about total force equal to ma, yeah? Total force equal to ma. Okay, that's in short, yeah? Now go deeper into the definitions of Newton's second law of motion. The rate of change of momentum of a moving body is proportional to the net force and in the same direction as the net force acting on it. So first of all, rate of change of momentum. What is it? Rate of change of momentum is actually dp over dt. Rate means the time, okay, and momentum, change of momentum is, you know, the change of momentum, delta p, yeah. Rate means the delta t. So when we have a delta p over delta t, that's called rate of change of momentum. We also can write it as dp over dt. Okay, rate of change of momentum. Okay, so rate of change of momentum is dp over dt. Okay, it is proportional, yeah, proportional to the net force. Net force is total force, or we call the resultant force. Okay, this is the resultant force, and in the same direction with the net force acting on it. So this is dp dt is proportional to the net force, or net force is proportional to the rate of change of momentum, and they have the same direction. Okay, they have the same direction. Both of these are vectors. They have the same direction. Okay, now we derive from here, and what do we get? Okay, so total force actually is the rate of change of momentum. Okay, so we know that momentum is actually mass time velocity, isn't it? Momentum is mass time velocity. So substitute into the momentum, and given in our syllabus, we already make the mass constant. Okay, we already made the mass constant. Okay, we don't think about change of mass. Okay, we don't think of change of mass, but in other syllabus, actually sometimes the mass do change. Okay, mass do change, but in our syllabus, we made the mass constant. Okay, made the mass constant. So we no need to differentiate the mass with time. Okay, so the mass, which is a constant, can be taken out. It can be taken out because it's a constant. When a constant undergo differentiation, it back to its own, mass. So mass can be taken out because it's a constant. Now left with the velocity. Velocity change. Velocity change with time. So dv dt, we get acceleration because we know that differentiate velocity with time, we get acceleration. Okay, or we can say acceleration is the gradient of velocity time graph. It's the gradient of velocity time graph. So okay, so dv dt become a. So that's Newton's second law of motion. Newton's second law of motion is actually total F equal to ma. Total F equal to ma. So we got a new relation between acceleration. You see that? We get a new relation between acceleration and the resultant force. So acceleration is a vector. Force is also a vector. So acceleration has direction. What is the direction of the acceleration? It follows the direction of resultant force. Okay, so we can say instead of saying that rate of change of momentum proportional to the net force, we also can say acceleration is proportional to the net force and also same direction with the net force. We also can say, last time you say that total force proportional to the rate of change of momentum. Now we also can say the other way around. The total force is also proportional to acceleration. So we can say that the higher the resultant force, the higher the acceleration, and also the direction of the resultant force is the same as direction of the acceleration. So this one has the same acceleration, has the same direction as the resultant force. Like look at this object. Okay, this object. So let's say the acceleration is to the left. Okay, let's say the direction of acceleration to the left. So what do you think is the direction of the resultant force? Resultant force also to the left. Okay, because the resultant force follow the direction of acceleration, or we also can say acceleration follow the direction of resultant force, or we can say that the external force is much bigger than the friction. That's why the resultant force is to the left. To the left. To get that is a resultant force equal to the external force, which is bigger, minus the smaller force. We get the MA. We get the resultant force. So the acceleration actually follow direction of the resultant force. Okay. Yeah, the external force is bigger than the friction. That's why acceleration to the left, resultant force also to the left. There is a remaining force. Yeah, that means after the external force minus the friction, there is remaining force. Remaining force or net force or resultant force. There's remaining force to the left. There's resultant force to the left. Okay, the remaining force is actually equal to MA. Okay, understand? So that's for so the acceleration must always follow direction of resultant force. So this total F equal to MA sometimes can be in X component, sometimes can be in Y components. Later I will show you, like you see this acceleration sometimes can be in X component, sometimes acceleration can be in Y component. So like this one you see, this is actually acceleration in X component. This acceleration in X component. So this total force also in X component. So sometimes like horizontal surface, of course the acceleration is in the X component. The resultant force also in the X component. But sometimes object is moving vertically, like this is a this is an elevator, is a lift, is a lift. Okay, it's a lift. So the motion is vertical. Motion is vertical. This one acceleration in Y component. This one acceleration in Y component. So the resultant force also in same direction with the acceleration. The resultant force same direction with the acceleration. If acceleration go downward, resultant force. So if acceleration go downward, the total force, the resultant force also go downward. Yeah, resultant force follow the direction of acceleration. So if acceleration in Y component, so the resultant force also in Y component. So sometimes we have acceleration in X component, sometimes we have acceleration in Y component, sometimes we have resultant force in X component, sometimes we have resultant force in Y component. So depends on questions. Okay, so depends on question. We have X component, we have Y component, resultant force and acceleration. Okay, now sign convention. This is one very important thing, how to put the sign convention. Especially just now I did say that why okay, I want to put something here. This one is the X component. Yeah, total Fx, Max. Okay, how do I get this actually? Why we say that external force minus the friction? Why not we say that, we see that, why not force to the right? Okay, why not force to the right is positive, force to the left is negative? Because before that we in the Newton's first law, we learn a different thing, isn't it? Newton's first law of motion, we learn that force to the right must be positive, force to the left must be negative. This one is actually a system that we create ourselves. Yeah, we can also put force to the left as positive, force to the right as negative. We can put like that, we can set like that. But to make things not jumble up, yeah, to make things easier for us, we just set it. We set it force to the right as positive, force to the left is negative. This is we set ourselves, yeah. The force upward is positive, force downward is negative. Okay, so Newton's first law, we set that force to the right as positive, force to the left as negative. But for okay, remember, see again, Newton's first law, for equilibrium where total force equal to 0, we set that force to the right is positive, force to the left is negative. But in Newton's second law, we don't follow that way. We don't follow that way. We don't follow that way. In Newton's second law, to make things easier, we follow acceleration. The force that follow acceleration, become positive. The force that opposite the acceleration become negative. So how do we do? Because in Newton's first law, we already says that force to the right as positive, force to the left as negative, isn't it? Like look at this example. If we follow the Newton's first law, force to the right as positive, force to the left as negative. So when we go to Newton's second law, for total force equal to ma, like this one, if the Newton's first law, we say that force to the right is positive, force to the left is negative. Okay, so what it becomes, what it becomes to the formula, yeah, what formula it becomes. So the resultant force in x component becomes positive Fk and then minus external force equal to max. Is it correct? Force to the right as positive, force to the left as negative. Is it the friction bigger than the external force? Do we use a smaller force to minus a bigger force? No, actually we use a bigger force to minus a smaller force, so that the remaining force is to the left, isn't it? We don't use a smaller force to minus a bigger force. So if we follow the Newton's first law, for the Newton's second law, it's incorrect. Yeah, so for Newton's first law, we use to the right positive, to the left negative. This one only for Newton's first law. But for Newton's second law, it's different. Newton's second law, we don't follow that. We use this system. Follow acceleration, we put positive. Opposite the acceleration, we put negative. So don't put this one, yeah? Don't put this one. Okay, don't say that, force to the right is positive, force to the left is negative. It becomes like smaller force minus a bigger force. Then suddenly you get the resultant force in the opposite direction. To the right, which is wrong. Actually, the resultant force is to the left, isn't it? So don't follow this. Okay, don't use the Newton's first law for second law. Okay, so how do we get these equations? One way you can say that big force minus a smaller force. Okay, the big force, we can say the big force minus the smaller force. You get ma. Okay, another you can say you take the big minus small. Big minus small to get the ma. You can use this way, or the other way is follow this sign convention. Okay, so how to use this sign convention? Follow me, yeah, follow me. So like this, total fx equal to, okay, so don't use this one, don't use the go to the right positive, go to the left negative. Don't use this one. So rub it off. Okay, like this. Look at the acceleration. The acceleration is to which direction? acceleration is to the left, isn't it? Acceleration to the left. So follow acceleration. Follow acceleration is positive. So we put here as positive. Understand or not? Follow acceleration, positive. Opposite acceleration, negative force. Opposite acceleration, negative force. Follow acceleration is positive force. Opposite the acceleration is negative force. So the force that because now acceleration is to the left, acceleration is to the left, so the force to the left is positive, and the force to the right, which is opposite direction with the acceleration, is negative. Okay, so now which force is positive? Which force is positive? Which force follow direction of acceleration? The external force follow, yeah, because acceleration to the left, this external force also to the left, so it follow direction of acceleration. So this external force should be positive. We put that as positive. Positive external force. Understand? Now, which force opposite the direction of acceleration? The friction. The friction opposite direction of acceleration. So this friction should put negative because it opposite acceleration. Understand? Opposite acceleration will put negative. Although it is to the right. Although this force is to the right, but we don't put that as positive. We put that as negative because it is opposite the acceleration. Understand or not? So we put as a negative friction. Negative friction. Okay? So equal to MA in the x component. So we got the equation already. It's the same, isn't it? You see? Is it the same with compared to the top one? Yeah. So we got the equation like this. So there are two ways. You can either use this system, big minus small. Yeah. What you can say, this is a big force minus a smaller force. Yeah. Big force minus a smaller force, you get MA. Or you can also use the system, follow acceleration. Follow acceleration is a positive force. Opposite acceleration is a negative force. You get this also. So you get the same equation. Either you use a big minus small force, or you use the follow acceleration, opposite acceleration to get the same equation. Okay? Just make sure that don't use force to the right positive, force to the left negative. So you confused. For if the question got involved acceleration, we need to follow acceleration positive, opposite acceleration negative. Although it becomes like going, yeah, usually we say force going to the right is positive, force going to the right is positive, but now no, yeah, now we look at acceleration. Yeah, we look at acceleration. We don't say we don't look at go to the right positive, go to the left negative. We don't look at that anymore. We look at entirely on the acceleration. Follow acceleration positive, opposite acceleration negative. Yeah. Okay. Look at this one also. Look at this one also. So let us use two systems. Yeah. First we use big force minus a smaller force. Okay. Let us use the big force minus a smaller force. Okay. Let's say we use the first system. Okay. Big force minus a small force to get MA. So which one is bigger? Which one is bigger? The weight or tension? Weight or tension? Look at acceleration also. If acceleration downward, the resultant force downward, that means the weight must be bigger. The weight must be bigger compared to the tension. Tension must be smaller. Yeah, tension must be smaller. So take the big force minus a smaller force, which is the weight minus the tension. So we should write like this. The resultant force. This one in the y component. Understand? The y component. Big force is the weight, minus the smaller force is the tension, equal to this one acceleration in y component. Okay, acceleration in y component. So big force minus the smaller force, because acceleration downward. Acceleration downward meaning that the weight is a bigger force compared to the tension. Okay, if acceleration upward, then is the tension bigger than the weight. Okay, so it all actually follow the acceleration. We can say actually these two system is the same. Big force minus smaller force, or we say follow acceleration, opposite action. Actually, these two thing is the same thing. Yeah, these two thing is the same thing. Okay. So we got weight minus tension, we get MA. Now the second way, yeah, look at the second way. Second way we use the follow acceleration positive, opposite acceleration negative. So okay, acceleration is downward. Acceleration downward. So which force we put positive if acceleration downward? If acceleration downward, that means the downward force you should put positive. The upward force which is opposite direction to the acceleration, you should put negative. Understand or not? Although we often say that force downward we put negative, isn't it? Force downward we put negative. This one, if no MA, if resultant force equal to 0, we put downward force negative. But if we got acceleration, then the downward force must compare with the acceleration. Like right now the acceleration is downward, so downward cannot be negative anymore. The downward force need to be positive, because the downward force is same direction with acceleration. It follow acceleration. So downward force is positive. Yeah, although we always say downward force is negative, downward force negative, downward force negative, downward force negative. But now we don't look at go up or go down. We look at acceleration. Now acceleration is downward. So the downward force you should put positive instead of negative. So the downward force now should be positive. So the upward force, last time we say upward force is positive. But now no, because acceleration downward, the upward force become opposite the acceleration. So the opposite acceleration you need to put negative. Understand or not? You put negative. So okay, so now follow this system. Follow acceleration positive, opposite acceleration negative. So which force you should put positive? The weight you should put positive. So put okay, first of all we write total Fy equal to, okay, the downward for the follow acceleration positive. So weight follow acceleration. Weight follow acceleration is positive. Weight follow acceleration is positive. The tension opposite the acceleration. Tension opposite the acceleration, we put negative. Tension opposite acceleration, we put negative. Tension opposite acceleration, we put negative. So equal to MAY. See, it's the same equation again. See or not? It's the same equation again. These two equation is the same. So it's still like big force minus a smaller force. Weight minus tension. So this is the sign convention of Newton's second law. Different. Yeah, the sign convention for Newton's second law is different from sign convention for Newton's first law. So remember that. Yeah, if Newton's second law, we need to look at acceleration. Go which way? Follow acceleration, positive force. The forces that are opposite the acceleration, we put negative force. Okay, so that's all for Newton's second law.